We spent some time with Lewis structures earlier in the course. Certainly, Lewis structures are an important way to represent organic molecules. But there's another way you often see organic molecules drawn, and that is with skeletal structures. A skeletal structure is one of many different ways to show the structure of a molecule. A skeletal structure is different from a Lewis structure, which shows all atoms and bonds. It is also different from a condensed structure, which shows the atoms but not specific bonds. In a skeletal structure, each line segment represents a bond. If no atomic symbol is shown at the end of a line segment, the atom is a carbon atom. Bonds to hydrogen atoms are not shown, but octets around carbon are filled out with single bonds to H. There are no lone pairs on carbon. Here is an example. If there is a carbon at the end of each line segment, then there would be 4 carbon atoms in this molecule. Notice that the left-hand carbon has 1 bond shown to another carbon. The second carbon in the chain has 2 bonds to other carbons. The third has 2 bonds, and the fourth has 1. In order to complete the octets around each carbon, we would need 3 hydrogen atoms around the carbons at the ends of the chain, while we would only need 2 hydrogen atoms around the middle carbon atoms. The chemical formula of this molecule would be C4H10. Here is another example. If there is a carbon atom at the end of each line segment, there would be 5 carbon atoms in this molecule. 3 of the atoms have only 1 bond to carbon, so they would each need 3 hydrogen atoms to complete their octets. The carbon that has 2 single bonds would need 2 more hydrogen atoms. The carbon that has 3 single bonds needs only 1 more hydrogen atom. The chemical formula of this compound is C5H12.